We're going to solve one-step equations. That's the objective for today. And in order for an equation to be true, there really is only ever going to be one value for the variable that could possibly make it true. So for example, if I say x equals x, that's obviously a true statement. Any number would equal itself. So for example, 19 is equal to 19. That's a true statement. This is actually called the reflexive property of equality. This is the reflexive property. Every number is simply equal to itself. That's a true statement. To solve an equation, you're going to use inverse operations. Inverse operations, that word sounds complicated, but it's not. If I were to say, well, I just did some addition and I'd like to hit the undo button, what would the undo button be? It would be subtraction. Subtraction is the inverse operation, and it undoes addition. And the same is true in reverse. If I just did some subtraction and I want to undo it, I would do addition. The same is true for multiplication. For multiplication, I would hit the undo button by doing division, right? And if I just did some division and I wanted to undo it, I would do some multiplication. So that's what I mean when I say inverse operation. The inverse operation of addition is subtraction. The inverse operation of multiplication is division. All right. Keep in mind, we want the variable to be all by itself. We want it to be simply alone. So it should say something like this when we're done. X equals some number or some other variable. It should be that simple. X equals something. So let's take a look at our first example. And what we're going to do is I'm going to just make a manipulation to this equation right here. Z plus 16 equals -4. And you're going to tell me whether or not you think the equation is still true. So if I did Z plus 16 minus 16 equals -4 minus 16, is the equation still true? Does it still have the same truth value? Or have I changed it so much that it is now no longer true? All I've done is subtracted 16 from both sides. And so the answer is that it's still true. I haven't disrupted the balance of the equation at all. I've actually simply done the same thing to both sides, and that means it's still the same expression. Nothing's changed. But something unique does happen where I have now created a 0 right here. 16 minus 16 is 0. So now I have Z plus 0 equals -20. I'm just adding these two numbers together, and I get a larger negative number. In mathematics, usually we don't write the zeros. So I'm actually just going to write this like this. Z equals -20. And so you see, I've accomplished my goal. I found Z, it's all by itself, and I used what is called the subtraction property of equality to do it. Of equality. So I simply subtracted 16 from both sides. I subtracted, so I used subtraction. And that got me a 0 right here where the Z is, and or on the side that the Z is on, so that I got rid of the other stuff, and Z ended up all by itself. Okay, so that's your first example. That's the subtraction property of equality. Let's do the addition property of equality now. So if I take this expression here, okay, -3 equals J plus 5, I'm going to make one simple addition to that, and then we're going to see if it's still the same expression. -3 plus 3 equals J plus 5 plus 3. Is that still the same expression? Or is it now that I've changed it so much it's no longer true? It turns out that actually it's still true. What I've done is I've added 3 to both sides. But because I did it to both sides, it's still a true expression. So it's this is called the addition property of equality. Property of equality. And you can see that right here something special happens again. I end up with 0 on the left-hand side. I have -3 and +3, and together that makes 0. So this is 0 equals J plus 5 plus 3. Let's call that 8. 5 plus 3 is 8, right? So let's call that 8. If I wanted to get j all by itself, what would I do? Addition? Would I use the addition property of equality, or would I use the subtraction property of equality? Let's try the subtraction property. So what I would do is say j plus 8 minus 8 equals 0 minus 8. You see, what I did was simply subtract 8 from both sides. So I didn't change the expression, I just subtracted 8 from both sides. And so the balance is still the same, the expression is the same. But now I've created a situation where I have a 0 right here. So j is now alone. 8 minus 8 is 0. So I get j equals negative 8. And that's the answer. If I wanted to check to see if I'm correct, here's what I could do. This is how you do a check. Let's take the original expression, negative 3 equals j plus 5. And let's put in the value we got for j. We said j was negative 8. Let's put that in right here where j goes. And let's see what we get. We get negative 3 equals negative 8 plus 5. What does negative 5 plus 8 equal? Well, it's negative 3. So I get negative 3 equals negative 3. And that, of course, is a true statement. That's true. So we've proved that j is negative 8 by doing this check.